Welcome back. Question 13. So we are still continuing with problem 0.6. Question 13. 13 says we should simplify x squared divided by 8 divided by x over 4. Basically, right? And we saw that when we have such where we can't factor neither numerator nor denominator, all right, then what we need to do first is just to change our division to multiplication by swapping numerator and denominator of the second part of our division, of the denominator of our bigger fraction. So it becomes a 4 over x there, okay? And then we are ready to then divide. So from here, it's 4x squared over 8x, right? So this x is going to cancel with one of the x's there, and then 4 divided by 8 is going to be 2, basically. So we are left with x over 2 as our simplified form. Number 16. 16 says c plus d over c divided by c minus d over 2c. Okay, same method, same thing applies. We can't factor numerator or denominator in this case, so we can just change our division to multiplication and see which factors cancel out and we simplify. So it's a c plus d over c times 2c over c minus d. C's cancel each other there, and we are left with 2c plus d over c minus d, basically. And that's the simplified form for that expression. Now, I'd like us to look at something more critical and more serious, which is the concept of lowest common denominator, using lowest common denominators to simplify fractions. Using lowest common denominators to simplify fractions. Okay, so if you look at that, I'd like us to start with this basic one. This is question 29, okay, which is a basic one because the denominators are actually the same. So x squared divided by x plus 3, this is 29 of 0.6 plus 5x plus 6 divided by x plus 3. Okay, we saw this when we were looking at adding fractions, and we said when their denominators are the same, all you need to do is just to add up their numerators and use that common denominator. So it becomes x squared plus 5x, x squared plus 5x plus 6 divided by x plus 3, basically. Okay, and from here, it looks like we can factorize the numerator and have some of its factors cancel out with the denominator. So if we use our trial and error method to factorize that quadratic expression, we get factors of x squared are x and x, factors of 6 are 3 and 2, basically, all right? So this times this is 2x plus 3x gives me a 5x, which is my middle term. So that tells me these are my factors. So it's x plus 3 times x plus 2 divided by x plus 3. Common factors cancel out. we are left with x plus 2 as our simplified form for that fraction. Okay, let's take more examples. So that was a straightforward one where the denominators are common. So let's look at situations where the denominators are not necessarily the same. For instance, number 35, 1 over 3x minus 1 plus x over x plus 1. Okay, so with this, okay, so I want to add up these two fractions, basically. So the first step towards adding fractions whose denominators are not the same is to find the LCD, lowest common denominator. So in this case, our LCD, by definition, I define my LCD as the product of all completely factored factors, right? The product of all factors of the denominator without repetitions, okay? Multiply all factors of the denominators without repeating any factors. So I move term by term. So I go to this first term, its denominator, the only factor there is 3x minus 1. I'm trying to compose my LCD now, all right? So that's the first factor in my LCD. I move to the next term. Its only factor is x plus 1, and x plus 1 is not already appearing in my LCD, so I write it down. All right, and I've exhausted all my terms. So my LCD is then just that product in this case. Okay, so that's the first step, is finding your LCD. The next step is then multiplying each term, okay, by the LCD. Okay, so when you multiply each term by the LCD, and then you take, you divide everything by the common denominator. So this is then going to be 1 over 3x minus 1 times 3x minus 1 into x plus 1 plus x over 3x minus, or x plus 1, denominators are not the same. Multiply each term by the common denominator, 3x minus 1 times x plus 1, and then divide everything by your LCD times x plus 1. Okay, once you've done that, you'll see that some of the terms, the factors are going to cancel out. All right, this factor will cancel with this one. Let me just remove this. Okay, so this factor takes away, eliminates this denominator, and this factor eliminates this denominator as well. And we are left only with the common denominator as our final denominator. So this whole thing will become, from this term, we are only left with x plus 1 plus, from this term, we are left with x times 3x minus 1, all divided by common denominator. Okay, that is how LCDs are done, basically. So you can simplify further by opening up these brackets and adding like terms, but I don't think it will change anything much, because it won't be canceling with any of the factors in the denominator. So that is then the simplified form for that question, that fraction. Okay, let's look at more examples that require the use of LCDs. Look at number 37. 1 over x squared minus 2x minus 3 plus 1 over x squared minus 9. Okay, so the first step is to factorize all denominators. You can't find the LCD appropriately without your denominators completely factored. You can't do that. all right? Remember what LCD is. Product of all factors of the denominator without repetitions. The product of factors of the denominator without repetition. So if your denominator is not written in terms of its factors, you can then find the LCD. So the first thing, we factor our denominators. How do we do that? First one is a trial and error type. The second one is a difference of squares. So looking at the trial and error, my factors for x squared are x and x. My factors for -3 are -3 and 1. Cross multiply, this times this is x minus this times this is 3x. This minus this is -2x, which is exactly my middle term. So that tells me these are my factors. So it will then be equal to 1 over x minus 3 times x plus 1, right? These are the factors of this denominator, plus 1 over difference of squares applied on this gives us x minus 3 times x plus 3, difference of squares. Okay, if you don't remember the difference of squares formula, quickly go back to previous videos of chapter 0.5 and look at how we apply the difference of squares. All right, so that said, after factoring all my denominators, next step is then to determine what my LCD is, lowest common denominator. So LCD, multiply all factors of the denominator without repeating any. It's going to give you your lowest common denominator. So I'm going to move through the factors one by one. So the first one is x minus 3. My LCD is empty at this point, so I include my x minus 3 there. I move to the next one is x plus 1. I look into my LCD, I don't already have x plus 1, so I include it there. Then I move to the next one is x minus 3. I look into my LCD, I already have x minus 3, so I don't include it again without repetitions. Then I move to the next one is x plus 3. Look at my LCD, I have not had x plus 3 yet, so I include it, okay? And this is then my LCD. Once you have your LCD, multiply each term in the expression by the LCD, okay? And then cancel the terms that cancel, eliminating these denominators and having your LCD as the only denominator. So it's going to be a 1 over x minus 3 times x plus 1 times x minus 3 times x plus 1 times x plus 3 plus 1 over x minus 3 times x plus 3 times common denominator. Okay, divide all of this by my common denominator, x minus 3, x plus 1, x plus 3. Okay, so once I have this, I then eliminate these previous denominators. Okay, x minus 3 cancels with x minus 3, x minus 1 cancels with x minus 1, denominators eliminated. Same thing applies to this one, denominators eliminated. So I am left with, from this term, only x plus 3 plus, from this term, only x plus 1, all of this divided by my common denominator down there, x minus 3 times x plus 1 times x plus 3. Okay, and that is then the simplified form. So I can open up these brackets and add and subtract like terms basically. All right, if I decide to do that, then my simplified form will then be this up here. Okay, so it becomes x plus 3 plus x plus 1 basically over LCD, which is x plus x is 2x plus 3 plus 1, 4 over LCD. Okay, and that's the simplified form for this sum here, the sum of these two fractions. So that's how that's the idea of LCDs. Let's take more LCD examples for clarity. Look at number 40. Number 40. 40 says, given x plus 1 divided by 2x squared plus 3x minus 2, and then x minus 1, it's not a plus, it's a minus. So minus x minus 1 over 3x squared plus 5x minus 2 plus 1 over 3x minus 1. Okay, so as we said, the first thing to do is to make sure all your denominators are completely factored. All your denominators are completely factored. Okay, once your denominators are completely factored, then you can go ahead and so let's then start by factoring our denominators. So this one by trial and error, this one by trial and error, this one is already factored, all right? Cannot be factored any further than this. So for the first one, this one, the factors of 2x squared are 2x and x, while the factors of negative 2 will be negative 1 and 2, basically. Okay, we cross multiply. 2x times 2 is 4x. X times negative 1 is negative x, which gives me a 3x, which is exactly what I have in my middle term. So that tells me these are my factors for that first one. So the first one gives me the x plus 1 over 2x minus 1 times x plus 2 minus x minus 1 over. Let's look at the factorization of this expression. So that one will be, we look at the factors of 3x squared are 3x and x. Factors of minus 2 are minus 1 and 2. Okay, cross multiply. 3x times 2 is 6x. X times negative 1 is negative x. 6x minus x is 5x, which is exactly my middle term. That tells me these are my factors. Okay, so it's a 3x minus 1 times x plus 2, basically, plus 1 over 3x minus 1. So this is my fraction with its denominators fully, completely factored. Next step is to find my LCD. LCD, multiply all factors of the denominator without repeating any. So I moved through my factors one by one. So first factor is 2x minus 1. I write it down in my LCD. Next factor is x plus 2. I check my LCD. I don't have any x plus 2 in it, so I write it down. Next factor is 3x minus 1. And look at my LCD. I don't yet have 3x minus 1 in it, so I write it down. Next factor is x plus 2. I look at my LCD. I already have x plus 2 in it, so I don't write it anymore, right? Because we don't need repetitions. Then next is 3x minus 1. I look at my LCD. I already have 3x minus 1, which is this, so I don't write it anymore. So this then is my LCD. So once you have your LCD, the next thing to do is to multiply each term by your LCD. Multiply each term by that LCD and see the terms that cancel, all right? So we get x plus 1 over 2x minus 1 times x plus 2 times 2x minus 1, x plus 2, 3x minus 1, minus x minus 1 over 3x minus 1 times x plus 2 into 2x minus 1, x plus 2, 3x minus 1, plus 1 over 3x minus 1 into 2x minus 1, x plus 2, 3x minus 1, LCD. Then I cancel out, eliminating these denominators. 2x minus 1 goes with 2x minus 1, x plus 2 goes with x plus 2, 3x minus 1 goes with 3x minus 1, x plus 2 goes with x plus 2, 3x minus 1 goes with 3x minus 1, okay? And from this first term, I'm left with x plus 1 times 3x minus 1, okay? X plus 1 times 3x minus 1 minus, in the second term, I'm left with x minus 1. I'm left with x minus 1 times 2x minus 1, all right? X minus 1 times 2x minus 1. And from the third term, I'm left with, look at the third term, I'm left with 2x minus 1 times x plus 2. 2x minus 1 times x plus 2. All divided by my common denominator times x plus 1 plus 2 times 3x minus 1. Okay, and then you can open up these brackets, add and subtract like terms, and simplify, basically. So for the sake of this video, I will not do that multiplication, but you can multiply in the brackets the way we saw how to multiply algebraic expressions, all right? Do this multiplication, do the same for this one, same for this one. Then you add all the terms in x squares, all the terms in x, and all the constant terms. Divide everything by the common denominator to get your final answer. Okay, so that's basically that about simplifying fractions. That's it for this video. Thank you very much.